This has, most of the common chemicals. Not everything. It's not comprehensive. Some stuff is missing from this chart. And there are two reasons it could be missing. The two reasons are, obviously these can't be completely comprehensive because there's enough room. There are two reasons, though, something might be missing from the chart. One, it's not very reactive. And so one of those species is like phosphate. Phosphate is a pretty decent base, but we don't really consider it a good oxidizer, good reducer. So it's not really on the chart here because it's not very reactive. Carbonate, same thing. Carbonate's not so reactive. And so there's some species that don't occur on this chart because they aren't that reactive. But then there are species that don't occur on the chart because you're kind of expected to know them. So for example, ethanol. Ethanol, what would you consider ethanol? A good oxidizer, a good reducer, electron rich, electron poor? Well, one thing is ethanol is very flammable. Like all alcohols, they're flammable. And so if it's flammable, like wood, what is wood? Is wood an oxidizer or is wood a reducer? I mean, if you're going to build a wood fire, I know what the oxidizer is. The oxidizer is oxygen, and therefore the wood must be the reducer. Methane. So methane, reducer or oxidizer? It's a reducer. All reducers have something in common. What do they have in common? They're electron rich. And so some of these species, they're just expected to know. For example, methane, you're expected to know this is a very good reducer. But when you look at methane, is that really electron rich? We're not talking about its acid properties here, but this methane is its redox properties here. Is that electron rich? It doesn't really look rich in electrons, right? But the only way we can tell if it's rich or if it's poor is by figuring out the what? We have to figure out the only way we can tell if it's electron rich or electron poor is by figuring out the oxidation state or oxidation number. What is oxidation state? The charge on the atom. So when we do that, what is hydrogen? We follow the rules. The rules are do hydrogen. Hydrogen would be plus. We got 4 of those. And that means carbon must be -4. And so carbon with a -4, is that electron rich or electron poor? It turns out the carbon with a -4 is electron rich. And so that means methane is a good reducer. It should react with oxygen, and it reacts with oxygen very violently. There's methane explosions all the time. There's a methane explosion in New York City that brought down a building, I think, like a 3-story building or something like that. And so it's very reactive. And so there are other species that don't occur on the chart, but you should know. Methane's one of them. Methane's not on this chart, but methane's probably the most common reducer you use. Here, ethanol. Ethanol CH3CH2OH. Is this electron rich or electron poor? Well, you might think, well, maybe it's an oxidizer because H. If you look at H, it's plus. H with a positive charge, that must be electron poor. But we have to put it in context. We've seen H with a positive charge before. We saw it in water, H2O. In water, H is positive, O is -2. And so, does that mean water is a powerful oxidizer because it's electron poor, each hydrogen is electron poor? Or does that mean water is a powerful reducer because oxygen is -2, it's electron rich? And so we have to put interpretations on these numbers. And the way we do that is we know the reactivity. How reactive is water? Is water highly reactive or unreactive? Water is unreactive, right? It's pretty stable stuff. It doesn't really react with much, except sodium metal. Sodium metal, the hydrogens were able to oxidize the sodium metal because sodium is so easy to oxidize. But other than that, water is pretty stable stuff. And so when we see H in the positive state, it doesn't really signify anything. That is, it's not really that significant. And the same thing with O and -2. So what we say is hydrogen is perfectly happy being plus, oxygen is perfectly happy being -2. And so it's really the carbon here that's lending this. And so we do the same thing. This is ethanol. Maybe what I'll do is I'll write ethanol not as this is called a condensed structural formula. It tells us a little bit about the structure. I'll just write it as a regular molecular formula, which would be C2H6O. If I write it like this, how do I assign the oxidation states to this? Which one goes first, carbon, hydrogen, or oxygen? Hydrogen goes first at +1. So each hydrogen is +1. What's oxygen? -2. Okay, that means carbon must be, well, if this is +1, we got 6 of those. That's +6, positive charge, -2 is +4. This must be -4. So that means each carbon must be -2. So if each carbon's -2, then that means it's electron rich, electron poor, or what? It's electron rich. Not as rich as methane, but electron rich. And so ethanol is a good reducer. Ethanol is very good. I mean, look how flammable it is. In fact, all these metals are highly flammable, because they're all pretty good reducers, like wood. Actually, these are better than wood reducer. Ethanol, highly flammable. Why? Electron rich. What about, is this oxygen electron rich? Would you consider the oxygen electron rich? No, I would not consider oxygen electron rich, right? Because it's happy as is. Look at water, happy as is. Would you consider fluoride electron rich? I mean, fluoride has that extra electron. Would you consider that electron rich? No. No, I consider fluoride happy as is. It's not going to want to lose that electron. It's just got it. And so some of the species, they don't occur on the table because you should be able to figure them out. Other species as well. We can see. But anyway, we'll go on with this. This electron bridge. So that was sodium nitrate. And for sodium nitrate, does sodium nitrate have much in the way of metathesis properties? Sodium nitrate have much in the way of, no. Group 1 salts are all soluble, nitrate salts are all soluble. It doesn't have much in metathesis. In fact, metathesis, nothing, no reaction. Acid-base properties, nitrate is a base, but it's exceptionally weak base. So weak we wouldn't really consider it. So nitrate, sodium nitrate's not really acidic nor basic, it's just neutral. Nothing, no reaction. And so the only properties sodium nitrate have are redox. Sodium ions, are those what? Sodium ions over here would be oxidizers, but pretty poor oxidizers at that. However, nitrate is up here. Nitrate is on the stronger end rather than the weaker end of oxidizers. And so it looks like a mid-range oxidizer, right? So nitrate is a moderate, maybe moderate to strong oxidizer. Here. Moderate to strong. In order to be strong, there's one ingredient that's missing here. What is it? It's H+. Why do we need H+? To form waters. Waters being stable. So the H+ is missing here, and so it's going to make it a little less strong. And so nitrate is a powerful oxidizer. Oh, well, I shouldn't say powerful. Nitrate is a good oxidizer, let's say, in the presence of H+. And so overall, sodium nitrate, we would say, as far as chemical reactivity goes, we would say it's an oxidizer, which I saw a number of people put sodium nitrate is an oxidizer. It's not really acid-base, it's not really metathesis, it's an oxidizer. Well, to get a better feel for the, well, let's look at this next substance. Ammonium nitrate. Why don't you do ammonium nitrate and tell me what you come up with for properties? You could just do this.